Wi-Fi Sheep would like to say a huge thank you to all of you that kindly support us. Help us continue to bring new videos like this. Join patreon.com/Wi-Fi Sheep from just $1 a month. Hello and a warm welcome back to youtube.com/Wi-Fi Sheep with me, Tom. Before we begin, let's welcome two new Patreon backers to the channel, Lee Reiner and Jeff Ledger. They join our ever-growing list of YouTube members and Patreon channel backers. Thank you so much for your kind and continued support. If you want to help out this channel, you can join them either via YouTube channel members or by joining our Patreon at patreon.com/Wi-Fi Sheep. Now back to today's video, and I have an event coming up in May 2023. The National Museum of Computing at Bletchley Park, Buckinghamshire, England are running a 2-day weekend event on May the 20th and 21st. Called the Econet Party, the museum is going to attempt to create the largest vintage Acorn Econet network on site over the weekend. But they need enthusiasts' help to bring equipment and hardware to the museum to join this giant network. Naturally, I decided I wanted to join in, but it means getting suitable hardware, in my case a 1986 8-bit Acorn BBC Master system, up and running in time. This video is sponsored by PCBWay.com, offering services such as 3D printing, injection moulding, CNC machine tooling, sheet metal fabrication, and of course turnkey PCB manufacturing. Take a look at PCBWay.com/projects and all the amazing things people are creating with PCBWay's wide range of production tools and services. So don't miss out. Sign up for your free account today at PCBWay.com. Details and links are in the description. So this is my main BBC Master 128. It's a Generation 1 128 from 1986. And it's one of the very last BBC Micro machines Acorn ever made. They stopped making these around 1993 and they were withdrawn from the market in 94. The main buyers of these in the end were the education market, with schools wanting to buy newer or additional hardware to run their BBC Micro software from the 1980s. Hence, although these things were considerably more powerful and had a lot more RAM, hence the 128, 108K as opposed to 64 or 32 of the earlier BBC Micros, they were very much throttled back in order to be backward compatible with original BBC Micro software. So very little software took use or made use of the additional hardware, speed and RAM. Anyway, as I said, this is the machine I want to take, and it's been installed a little while and it's back up here on the desk, and I like to have at least one BBC Micro permanently set up. However, there's a slight problem. Allow me to show you. We power up. Yeah, and then you get errors like this, so it's sort of working, sort of isn't working, and you also get things like this is not a language. Basically what's happened is that the CMOS batteries, which is unique to this model of the BBC Micro, early BBC Micros didn't have backup batteries or CMOS batteries inside them as standard. The Master 128 did, so most of my BBC Micros don't actually have the lids screwed on, so you can just take the lid off quite easily. There we go. And inside, so this is a battery holder which I put in, and I put in 3 AA batteries. I could do with redoing the tape. Yeah, it was done a little while ago, but I think these AA's, they're just standard AA's, not rechargeables or anything, but I think they've now expired. Definitely being MacLeod brand AA batteries, I think they've expired. So we'll take the batteries out. I'll replace them with some fresh. Yeah, not sure when I did that, but it was a few years ago now. So obviously these batteries, they don't get recharged, so they do expire. So let's just take these out. And yeah, we'll just try and redo. We can redo some of this tape. It's not terrible, it's just protecting the resistor and the diode in here. But obviously you don't really want bare metal pieces lying around, so I'll just put on a piece of electrical tape. Yeah, and I'll just wrap that one up as well. Yeah, that'll be okay. So I've got these new batteries. These are just MacLeod standard domestic AAAs. And as I said before, I put a little Velcro pad on this, and there's a little Velcro down here, so the batteries just stick back onto their Velcro pad. That stops them moving, and that'll be okay there. Okay, so then let's power back up. And this is kind of what I would expect to see. So we hold down Control and brake, and we'll get something like that says bad command. Again, that's normal. So what we need to do now is to put in a new CMOS setting, so the machine won't load to basic and it will just keep stalling all the time until we actually set it up correctly. This is standard for pretty much all 128, so even if you have one refurbished, fully working new batteries, you've still got to do this setup, otherwise it does not work. Okay, so I've just done a control brake and things are looking a little bit better. You'll notice my tube interface has now come in, but you'll see it still says this is not a language. And if I try and ask for basic, it hangs because there's nothing there. So what's going on? Well, we'll control brake and let's have a look at status. So we can go star ST, or yeah, star ST, and that's the status. So that's how everything is set up at the moment. And let's have a look at ROMs. So star ROMs. And you'll notice that it says that ROM C, basic 04, that's basic 4, is unplugged, which means it can't see it. It's also interesting that it notes the Acorn ADFS is also unplugged. So we could do with both of those being active and working. So if I say insert 12. Now if I check back to ROMs, you'll see now ROM C. So basically it goes up in hex. So after 9, A is 10, B 11, C 12, and so on. We'll also want to insert the ADFS, which is, where are we, 10, 11, 12, 10, 11, 12, 13. And again, just check ROMs. Okay, so now if I go control brake and do a reset, there we go, we're working. We've now got basic installed and running. So if I now power cycle the machine, we'll turn it off. And we'll turn back on again. There we go, we're up and running, and it's saving the settings through the new battery backup. Right, so now we've got the target BBC Master 128 pretty much up and running quite well. I want to show you this, which is a near identical Master 128. I think it's the same vintage 1986-87 era. This one, if you can see, is not actually in as good a condition, and it's been a spares machine which I've had for a little while now. So with things like we're missing a key, for example, it's extremely dirty, lots of scratches. It's almost gloves territory. It's not quite, but it is in horrible condition. But I do believe, if I remember correctly, it does work okay. So let's just take the lid off. It doesn't have any screws and anything, so everything is loose. But inside, I'm just going to switch to the camera so I can show you this. So I want to show you what this actually has that I'm interested in, which is this daughter card. So this is an Acorn Econet module, and this is the networking card, and this is what we're interested in and we're going to need in order to make my other machine be able to join the museum's Econet network. So this is held in, it's just got 2 clips, so it should hopefully be able to lift, and I'm just seeing if it's held in by anything. It's just a connector here and pins that connect it down. So we'll get out in a minute. I just want to show you here, there's an EEPROM, and you can read it. It's labelled M series, well, that's actually coming off, but it's okay. It's not a windowed one, but okay. So it's labelled M series ANFS, which is Acorn Network Filing System, which is what we're going to need in order to hopefully jump on this network and be able to read files from the server, which will be hosted by the museum. Now, I don't know if this card works. I have no reason to believe why it wouldn't work, but we'll see. But the first thing we need to do is try and get the card out, which, if I break the card, we're done. Got a very rusty pair of pliers here. Let's see if I can just pop these. I don't think that's going to work. Just pinch them enough I can release the card. Trying to be as careful as possible, because if we break this, that's it. Okay, that's loose. I mean, this card probably hasn't been released in this machine in, God, assuming it's stock or near stock, it was done and put in the 80s. Oh, nearly. Ah, there we go. There we go, we're out. And pins are okay, and there's a sticker underneath. Turn that around for you if anyone's interested. There's the serial number. So the card, yeah, it's looking okay. That's the card out. And I'm just looking at this ROM here. And I've got a screwdriver handy. If I have, I can bend all the pins up in the wonderful way that I'm so good at doing. Screwdriver's a little bit big, but it should be alright. Just to very carefully, because I haven't got a chip puller. I should get a chip puller. I haven't got one. So we just want to just loosen it 'cause it's a little bit crusty. And I think we're going to need this as well. So, oh, nearly. There we go. That's come out. Take the sticker with it so we know what it is. And I think in this machine, that's probably everything we need. Okay, so the board itself, as I said, looking all right. It is a little bit dirty, and also we've got the EEPROM itself with the sticker. So we'll just take the sticker off, and you can see here, if I just bring it into view, it's a NEC or NEC Island IC. So I've got some surgical spirit, which is basically alcohol, and Q-tips, and I'm just going to give tops of chips and also the legs just a little bit of a clean. No sign, a bit dulling, but no sign of any rust or any major corrosion, which is good. So there's a good chance, a very good chance, this all might work. Also remember to do the backs of the legs as well. And then the main card itself, it's just dusty really. That's a Motorola part there, and there's a couple of their logic ICs. And the capacitors look alright. You've got a resistor array here, and that all looks fine. Can't see any bulging or any leaking caps. Underside's looking very, very shiny. I'll try not to get anything on this, but I may need to try and stick that back down. And again, I'll just run a bit of alcohol just onto these pins, which have stayed relatively straight, which is good because they're long pins. The longer the pin, the more they tend to bend, so that's actually looking really promising. And yeah, they're not bad actually, they're not bad at all. So we'll just do the smaller ones here. Yeah, you can use a glass fibre brush to clean up ICs if they're particularly bad, but that don't look bad at all. So that's the card done. And there's our chip, or EEPROM I should say. And I'm just going to use a dry Q-tip just to clean any residue. Make sure that's dry. So I want to stick this adhesive label back on, and what I'll use for that is just some glue stick. I actually use more for 3D printing. Just need not much, just a little bit, just on the end. Bit of adhesive on. Not much. There we go. We can pop that back on there. There you go. That's fine, and that'll be fine. You don't use anything else, and you start using things like double-sided tape or anything, it starts sort of stack up and gets a bit ridiculous in the end. So, but yeah, that'll be fine. That's not going anywhere. Right, I think we might be ready to try and install these into the other Target Master 128. Here's the machine we've been working on, and we're nearly ready to go. We'll just take the lid off this one. And I'll explain in a minute what I've done. I've changed the configuration on the daughter cards we've already got in the machine, but for the moment we're interested in just setting up our Econet networking card. So here on the top view you can now see where we need to insert the card. So here are the 2 pin sockets. It's a little bit dusty inside actually. So what I might just do is just blow a bit of air in. There we go. Okay, so should be a simple case to just insert a card. The nice thing about the Masters is that the actual connector for the DIN type jack socket that's used for Ethernet connections is already there present on the Master systems. I think they had them in by standard. The earlier BBC Micro Model Bs didn't have it. You had to actually solder on a new jack. So that's kind of another reason why I'm going to choose a Master over a Model B to take to the museum. Just because one is a slightly better machine, slightly more capable, and it has things ready to go. Just have to click cards in rather than have to take whole bits of the machine apart. So hopefully, bit of luck, that fits in. And yeah, something like that, I guess. I have no idea. I don't have any Ethernet networking capability here, so I can't test anything. So that's that in there. And then just moving along, we've got one ROM. Now, this was a combined EEPROM. So this was your basic operating system, twin disk controller type system. So ADFS and DFS. And I think it had a few other programs like View, which is a spreadsheet. I think it had a word processor. And again, I think I mentioned a terminal type program, which you may end up needing to use with our Econet module. So really, a Master on its own only actually requires one socket or one EEPROM. However, I need to add a few more things, and the first thing I need to add is our ANFS networking filing system, which we just borrowed out the other machine. So let's put that into this. We can get it in. If it'll go. And be very, very careful to make sure that all the pins are actually engaged, because you don't want to push down and then there's a pin that's not in the socket. You can end up damaging first the socket and also the chip. So I think that's okay. Yeah, that's looking all right. There we go. A little bit of resistance on that, but I think we're in. Yeah, I think that's in. So let me just take out the little plastic tray. These, by the way, here, just show you, these are where the cartridges would plug in. Now, I was using a cartridge with the system because I had to take some EPROMs out because I used space is bankable with, and you can see here as 2 memory SRAM chips, and that allowed you to soft load ROMs into the machine if you didn't have physical EPROM chips. Unfortunately, you couldn't have EPROMs here and use the soft loading capability, and I think there was a game or something that ran and it needed the extra RAM. 128, ironically, it wasn't enough. So I believe I need to take this jumper here and put it back over here, and that should activate the 2 slots again, which means I've got them here. I can actually put some of these ROMs back into the machine because I had them on this cartridge daughter card. And you can see, unfortunately, when it goes into the machine, it hits the flaps and it kind of starts to rip the labels off, which isn't good. So I think I want both of these back in the machine. So let me just grab the screwdriver and carefully take them out. Okay, so the first one here is Turbo MMC or Turbo SPI, which is the same as MMC, and that's for using a SD card based system which uses the user port, and that can be very useful for loading games and things in. It needs its own drivers, and those are basically the drivers for it. So this is how you actually manually load and install system drivers into a BBC. So that one's in there. And then in the final slot, and I need to repair the label, is the NULA, and that's the ROM needed for, it's not actually needed to be fair, but it's the video NULA graphics card which I have fitted to this machine, and this is the ROM which gives some software support for the hardware. So we'll pop that one into the final slot. Again, being very careful to make sure we're not chewing any pins. Also, I should note that all the notches face this way into the machine. So if the notch is facing out towards the edge of the case, then that's obviously incorrect. So, right, and then let's pop the speaker back. And you can see why you have to take the speaker and the cartridge cowling out, because you can't fit the final EEPROM in with it in situ, but it just clips back in place. Okay, so we've got everything pretty much installed, as I was hoping. Let me just show you very quickly what I've done here. So I originally had a Raspberry Pi A+ board, which is about that kind of size, fitted upside down, via GPIO pin, slotted straight into the adapter board for the PiTube Direct interface, which allows you to have an internal coprocessor or external from Model B, allowing a Raspberry Pi to emulate all sorts of things like a Z80, 6502, even native ARM 32-bit mode. Now, the later revisions of the SD card based software actually allow for a HDMI out video via the Raspberry Pi controlled from the terminal side of your original hardware. Unfortunately, on the original Model A I had, or Model A Plus, sorry, I had in here, the HDMI cable came out just about here, the socket, and it hit these 2 power leads, meaning I couldn't get a cable through. So I swapped it out for this Raspberry Pi Zero, which is roughly the same spec as an A+, and it has a mini HDMI here, with an adapter to adapt it up to full-size HDMI that allows me to get a cable out. Now, admittedly, there's no immediate space to get a cable from there outside the machine with the case on, but running it with the case off, I should be able to connect up video or HDMI lead. Right, so moment of truth, let's put the SCART into the RGB connector. So that's RGB DIN to SCART here on the TV. Might help if we actually plug the master in. Okay, and let's just power up. Okay, that's a good sign. So far so good. I should probably put this through the video capture card really, but I hope you can excuse the recording off the screen. Should be alright. That's looking very promising. I don't know if you can see this on the screen. I've got some sort of interference, which might be the video NULA card. Does seem to be a little bit prone to interference occasionally. I'm getting a little bit of something going on just here. It's not too bad, but yeah. Okay. So that appears to be working. If I break, you can see we've got the tube interface is running. So Acorn tube 6502, second 6502, 64K available. That's also working. So yeah, okay, that's brilliant. That appears to be everything on the system. So a few minor tweaks are still needed and the case still needs a clean, but overall I think I'm more or less ready for the event. If you want to join in, the links are in the description. Now, it's a 2-day event happening over the weekend of the 20th and 21st of May 2023. Just be aware I'm only going to be there for the Sunday, the 21st, but I will be at the museum all day Sunday. Now, you don't need to book special tickets if you're just visiting. Normal on-the-door entry prices apply, and the rest of the museum, including the LAN party event, will be open to the public as normal. So please do come along and support the National Museum of Computing, and I look forward to meeting you again in person. And who knows, maybe we can hang out over lunch. If you haven't done so already, please do consider liking and subscribing, and I'll see you real soon right here on the channel. Until next time, thank you so much for your company, and bye for now.